Hi, this video is for learning how to solve quadratics without using a quadratic formula. So mostly we're going to factor and do some completing the square. So this is a trinomial. We're going to factor this trinomial. So let's start with some parentheses, setting that equal to 0, because when we're solving for a quadratic, what we're actually looking for are the roots. Roots are also called x-intercepts, and you also can say that you are finding the solutions. So when somebody is saying, "Hey, solve these quadratics," these are the three things that you're doing, and they all mean the same thing. To make x squared, that's just x times x. Both of the signs are positive, so these are both b plus. And then you're just asking yourself, what multiplies to be 12? That adds up to be 7. And that's only if there's a 1 in front here. You can't do that if there's not a 1, if there's a number. And we're going to do a later example of that. But to make 12, you're either going to go 1 times 12, 2 times 6, or 3 times 4. So looks like 3 times 4 will add up to be 7. So we're going to say x plus 3 and x plus 4. We're going to split that down the middle. You need to set both sides equal to 0 because there's two parentheses. You have x equals negative 4. You have x plus 3 equals 0. You have x equals negative 3. Put your answers in solution sets because these are solutions. So negative 4 and negative 3. And if you wanted to graph this just to know what this looks like, because this is a quadratic, and you are solving, you're looking for the roots, your graph is going to have an x-intercept at negative 4, which is about here, and then also negative 3, and then your graph will go up like this. And then at some point, way up here, this line will continue, and up here, you're going to have an x-intercept of 12. This will go up, that'll go up. And that's because when you set x equal to 0, your y will equal to 12. So that's why it'll go up. It goes up on both sides, but okay. For this problem right here, this one, I'm going to factor out a 4. And when I do that, I get x squared plus 3 is equal to 0. This 4 does not, so when you split this up, 4 does not equal to 0. So you need to lose that. You can either divide by 4 or just eliminate it because you know that 4 does not equal 0. These cancel. You get x squared plus 3 equals 0. So now you need to solve for x. We're going to move the 3 to the other side by subtracting. So we get x squared equals negative 3. And in doing that, now we're going to square root both sides. You get x equals the square root of 3. Now, another way of writing that, because since we did start imaginary numbers, is the square root of negative 1 times the square root of 3. And we know that the square root of negative 1 is equal to I. We also know that I squared, if you square both sides, is equal to negative 1. But we're going to use this right here. So we have x equals I times root 3. When you take the square root of a value, know that that is plus or minus, and these are solutions. The difference between this problem and the above problem is that this problem has imaginary roots. So basically, if I were to draw an axis, which I'm going to do right here, and looking at this, I do have an x-intercept of 12 again, so that's way up here. We'll say that's, a y-intercept of 12. I'm not sure if my graph is on this side or on the right side. So let's just plug in negative 1 and see what's happening at negative 1. So 4 times negative 1 squared plus 12 equals 0. So we're looking for our x-intercept. So I'm going to say that equal to y. So this is going to be 4 plus 12, which is 16. So that means when x is negative 1, y is 16. So that's actually higher. So that tells me that my graph will come down like this on this side. I didn't ask you to find the vertex, so I'm not quite sure how low that does go, but do know that it does not cross this x-axis because it is imaginary, so it is going to float. There's no real solutions. It's only imaginary. This one, I'm going to factor to solve using factoring on this one. And this one, I'm going to solve using completing the square. Okay, so if I were to factor this one, first I would need to move the 20 back over. So I have x squared minus 8x minus 20 equals 0. So then I would factor again like this we did on the previous page, x times x squared. What multiplies to be negative 20 but adds up to be 8? And we're going to go with a negative 10 and a positive 2. You're checking the insides here and the outsides. So when you multiply these out here, you get negative 10x. And here you get positive 2x. And so that does make negative 8x. So that is what I'm trying to find. So I'm going to erase that. So then what we're going to do is we're going to split this up. We're going to set both sides equal to 0. X plus 2 is 0. So x equals negative 2. X minus 10 equals 0, so x equals 10. So my solution set is negative 2 and positive 10. And just know that, again, this is a quadratic. And in graphing this, I do have an x-intercept at negative 2 right here. And I do have an x-intercept at 10. And I do have a y-intercept at negative 20. I know that because if x was 0, y is going to equal to negative 20. So if I brought this way down here, we'll say that's negative 20. And so my graph will look something like this. It's my parabola. It'll come up. But just know that when you're solving, you are looking for the x-intercepts. And again, you're looking for the x-intercepts, which we just found. Those are also called the roots, and they're also called the solutions. I'm going to use completing the square to solve for this one. And so a couple of rules for completing the square, and that is your a term has to be 1, which it is, so we're good there. You do need to move any numbers or constants over to the other side, which is already done for you. So we have x squared minus 8x. And in order to complete the square, the rules are you're going to take half of the b term. So this is the b term. The b term comes from this y equals ax squared plus bx plus c. And b being the term right in front of the x, or the coefficient right in front of the x. So that's this value right here. So we're going to take half of that term. So we say negative 8 divided by 2, and that's negative 4. And then we square that. And then we're going to add that to both sides. So half of 8 is negative 4. Square that. Negative 4 times negative 4 is 16. So I'm adding 16 to both sides. You need to add the same value to both sides because it is an equation, which means it is equal on both sides. So if you do add something to one side, you have to add it to the other. Factoring is what you do next. So you're going to go x minus 4 times x minus 4. That's 36. You have x minus 4 quantity squared is equal to 36. Now, remember, you're trying to solve for x. And in solving for x, we're going to need to get the x out of underneath this square. So I'm going to move all this down a little bit. Okay. And so what's going to happen is when I square root both sides, I'm going to get x minus 4 is equal to plus or minus 6. And what that's going to do is I'm going to still solve for x. I'm going to move that 4 over. I get x equals 4 plus or minus 6. So that's going to be x equals 4 plus 6 and x equals 4 minus 6, which is 10, and negative 2, which is what we did get previously. Okay, this is just another way to solve it. You would, again, put your answers in solution sets. This problem, I'm going to solve this by factoring. And before I try to factor like this, I'm actually going to use the discriminant, which is b squared minus 4ac. And this is sort of a little trick to see if your equations are ever going to factor. I know you can try for a long time trying to guess what the answer or guess what you're going to check. But this right here will just tell me if it's prime or not. Does it factor or not? If it doesn't factor, I'm going to need to use the quadratic formula or completing the square. But let's just check. So b squared would be 121, which is 11 times 11, minus 4 times a, which is 6, times c, which is negative 10. So that makes 121, two negatives make a positive. So 24 times 10, which is 240. 240 plus 121 makes 361. And you ask yourself, is this a perfect square? It is. I believe it's 19 times 19. And so what ends up happening is not only do you know that this here is going to factor, but you also know, this being a value that's greater than 0, that you're going to have two real solutions. So it might look like that, it might look like that, but you will have two real solutions. Okay, so let's try factoring. So factoring, let's see. For 6, our choices are 1 times 6 or 2 times 3. I'm going to start with 2x times 3x. And for 10, my choices are 1 times 10 or 2 times 5. So I'm going to make these plus and minus, and then I'm going to try 2 times 5. Again, you check these two values, the inside and the outside. So you're going to get 2 times 3, which is 6x, and 2x times negative 5, which is negative 10x. And that's negative 4x, which is not what I want. I want 11x. So I'm actually going to erase this and try again, this being the guess and check method. This will be 5 here, 2 here. Checking the insides and the outsides, I get 15x. And then negative 4x, which does make 11x, which is what I want. So now I can, since I did factor that correctly, now what I'm going to do is I'm going to split this up and set both sides equal to 0. So 3x minus 2 equals 0, 3x equals 2, x equals 2/3. 2x plus 5 equals 0, 2x equals negative 5, and x equals negative 5 halves. So my solutions are negative 5 halves and 2/3. And again, if I were to graph this, my graph would look like negative 5 halves, which is what, 2.5. And so right about there. And then that's negative 5 halves. And then 2/3 would be probably right around here. And then my y-intercept is when x is 0, so that's negative 10. So let's just say it's here at negative 10. And so my graph is going to look something like this. It's not the vertex, it's just the y-intercept. This one right here, I have 4 terms, and it is a cubic. But what I need to do is I need to factor this by grouping. So I'm going to group the first 2 terms and the last 2 terms, and I'm going to ask myself, what can I factor out of both x squared, or this term, and that's an x squared. So what's left is a 2x and a 3, so plus 3. The objective for this is basically to get the 2 parentheses equal to each other, so you can factor those out again. So I'm going to factor out, I'm going to try to make this look like this if it's at all possible. And in order to do that, I would need to make this to be a positive 2. So I'm going to take out a 4, a negative 4. So I'm going to take out negative 4. And in doing that, when I say take out, what I'm really saying is I'm dividing. And so that's going to be 2x, and this is going to be plus 3, negative divided by negative. So now I'm going to factor out of this term and this term, I've got a 2x plus 3 that's common, so 2x plus 3. And then what's left is x squared minus 4 is equal to 0. Now, if this was quadratic, I would be done, but this is actually not quadratic. Okay, and so this is not quadratic because it's a cubic. See the 3 right there? So that actually means that I have 3 solutions. I'm still finding the x-intercepts, but I have 3 solutions to my answer. So I see that this is a difference of 2 squares, which is telling me that I still get this value here, but this is going to break down even further to be x plus 2 and x minus 2 equals 0. And now I'm going to split these all up, and I get 2x plus 3 equals 0. I get x plus 2 equals 0, and x minus 2 equals 0. So x equals 2, x equals negative 2, and 2x equals negative 3. Divide by 2, x equals negative 3 halves. So my solution set is going to be negative 2, comma, negative 3 halves, comma, and 2, which basically means that if I were to draw a graph of my solutions, I would get, let's see, an intercept at negative 2, at negative 1.5, and at positive 2. I also have a y-intercept of 12, negative 12. So what that tells me is that my graph is going to look something like this. Now, I'm not sure how high that's going to go, and I'm not sure how low this is going to go, but I do know it crosses at those 3 points, which are negative 2, negative 3 halves, and positive 2. And this is just a sketch of what it looks like. So that is how you factor quadratics and non-quadratic functions using factoring and some completing the square. All right, I hope that helped. Thank you.